السلام عليكم أبناء الطلاب كيف hello how are you doing it's me Murad Sultan Ezouidi Indonesian mathematical teacher. Last night we told about prepare for yourself for tomorrow to work through fifth degree from the equation, and we will try to use the discrete formula of me and start solving this fifth degree from the equation. Okay, so here we will start learners. I'll just start now with you. Prepare yourself, prepare calculators and paper sheets and so whatsoever. Okay, to start, uh, work with me at the same time. Okay, doing uh, doing solving this full equation. So the equation that we called yesterday learned is that this one. I already told that. Hi, my dear, it's me, Murad Sultan Ezouidi, the pioneer of mathematics, the Tunisian researcher, and the discovery of the discrete formula of any integral equation. Let's meet you tomorrow. I will be live my whole world. Now, learners, I'm live. The polynomial is that this is the equation is p of x equal x raised to the power 5 minus 66x raised to the power 4 plus 1815 x cubed minus 26,621 x squared plus 219,648 x minus uh, minus 966,000 and 669 equal zero. Therefore, I will start now. Learner, prepare yourself. I'm going to start this one to have x. Okay. Okay, the document will be open and we will work together as soon as possible. Figure out the value of the exact roots of this polynomial to the power 5. Okay. Now it comes here, number 16, example 16. What is it, example 16? Mr. Murad. Example 16 comes here. Okay, not this one. So prepare yourself, teachers and colleagues and professors and students to solve this problem to the power 5 using the discrete formula of Mr. Murad Sultan Ezouidi. Okay, it's very helpful for you learners to get to know about the formula. Okay, I'll just come here. Okay, here it is. Okay, okay. 11. Example 14. We reach 15 and we will solve 16. We solve 16 using the theory of Mr. Murad Sultan Ezouidi. Okay, so this is the example learners. Okay, this one is 16 is that. This is the room to the power 16. I'll try to enlarge this one. Okay, good enough. Okay, so this one learners is the room to the power 5. Now we are going to solve. Okay. So you can see this one. We have x equal x raised to the power 5 minus 66. X raised to the power 4, 850. X cubed minus 26,621 x squared plus 219,648 x minus 966,661. Okay, I'll just share this one for my colleagues first. Okay, control the chat. Okay, 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 so we got that. Now, learners, we want to find the coefficient of the new decimal formula, okay, that is relative to fifth, the original fifth degree formula equation. Now it's clear this is polynomial to the power 5, simply because the highest power is 5. So therefore, I'm going to calculate s subscript k minus 1 upon r. Let notes, let's say the node L0 for the 2 is 66, L1 for the 2 is 1850, L2 of OD2 is 26,621, L3 of OD2 is 219,628, and L4 of OD2 is 966,669. Okay, so you can see also this number is special, 96669. Now I will use this formula of me to figure out the value of S0 and S minus 1 and S1 and S2 and S3 and S4. Okay, let's focus on this. So I will now will substitute, I will substitute, I will substitute learners. Okay, k equals 0 in this formula of me. I will obtain immediately S minus 1 over the R equal 1, simply because it will be combination of n choose 0, which is going to be equal to 1. Now I will go to find a 0. Find a 0 level, just put k equal 0. We will write s subscript k minus 1 over the r equal the sum from 0 to k combination n minus r choose k minus r n raised to the power r between parentheses the 0 for the q raised to the power k minus r times n r minus 1 over the q. Therefore, you can, when you substituting, it will be 1 minus 1 will give you S0, you see, S1 minus 1 over the R will be equal to 0. This, it will give you the sum of the absolutes of the new fifth degree from the equation, which which have been to be equal 0. Okay, now I will make calculation. I will use my own calculator, Mr. Murad. I will make negative combination 5 choose 1 means negative 5 multiplied by 66 plus 5 times 66. Okay, this one my kids is gonna be equal to 0. Now I'm going to find the S1. I should substitute k equal to the discrete formula me. I will obtain immediately S1 of order R equal minus 1 minus combination 1 choose 1 times combination n choose 2 times n0 for the 2 squared plus n squared n1. Okay, now I will try to make bigger. Okay, like that. Now learners, it's clear that I'm going to find the value of this. So I should find the value of S1. Okay, I will just write minus 1 times 10 uh, because 5 choose 2 is 10 times 66 squared times 66 raised to the power 2 plus 5 squared means plus 25 times 1850. So this one is going to be equal to 1850. Okay, now I'm going to learn immediately to find the value of S2. To find S2, you should or you have to substitute for k equal 3 in the discrete formula of this multiple times Ezouidi. It will be S subscript 3 minus 1 will be equal to 2 of all the r equal the sum from 0 to 3 because the k is 3 combination n minus r choose 3 minus r and raised to the power r between parentheses the 0 for q raised to the power 3 minus r times and r minus 1 of all the q. So this one has to be equal learners after making after expanding it. Okay, for r equal 0, then r equal 1, then r equal 2. Okay, this is r equal 3, we give you negative combination n minus equals 1, n squared n0 for 2 raised to the power times n1 equals 2 plus n raised to the power 3 times 2. Now, learners, I'm going to focus on the last one, which is this. Okay, will give you the coefficient of the new fifth degree polynomial equation, and the formula has been written in terms of n and the third coefficient of my original fifth degree polynomial equation. This is have been generalized for any n polynomial equation to find the S2. Okay. Now I'll make my calculation numbers. I will just use my calculator. So we have here, what we have, I put this one here. So we have uh, 2 times 10, it will be 20, times 66, times 66 raised to the power 3, okay, minus 3 times 125, minus 3, okay, minus 3 multiplied by 25 only, multiply by 25, okay, multiply by 66, multiply by 66, multiply by 1850, plus 5 cubic means plus 125, multiply by learners 26,620. So this one has to be equally at 93,295. Okay, now we continue. We should, let's say, find S3. I will just substitute K equal 4 in this formula of Mr. Murad will be HSM. HSM. Okay. So I will write it as S4 minus 1 will give you S. The sum from 0 to 4 combination n minus r. So 4 minus r n raised to the power r between parentheses the 0.2 raised to the power 4 minus minus and r minus 1 of 4. This one has to be written as combination n choose 4 times n 0.2 raised to the power 4 minus n times combination n minus 1 choose 3 times n 0.2 raised to the power 3 times n 0.2 plus combination n minus 2 choose 2 n squared times n 0.2 squared times n 1 minus combination n minus 3 choose 1 n cubed times n 0.2 raised to the power 1 times n 2.2 plus n raised to the power 4 times n cubed. You can see this one, it's a common factor. I put it outside the parentheses, then I'm going to calculate the difference between these two exponents. So this one has to be written in fact with the last generalized formula, negative 3 choose 1, combination n choose 4, and 0.2 raised to the power 4, plus combination n is 2 choose 2, n squared, and 0.2 raised to the power 2 times n 1.2 minus combination n minus 3 choose 1 times n cubed times n 0.2 raised to the power 1 times n 2.2 plus n raised to the power 4 times n 3.2. So this one learns S3 will give you the value of the fourth coefficient of any n degree polynomial equation. Okay, because n here denotes the highest power of the polynomial value are working. So I will now calculate this using my calculator, of course. I will erase this one. So we have negative 3 times 5 is negative 20. Multiplied by 66 raised to the power of 66 raised to the power of with this of 3 plus 3 times 25 plus 7 plus 75 times 66 times 66 raised to the power of this square. Multiply by 1000 multiply by 1000 and 50 1150 minus 2 multiplied by 155 means minus 250 minus 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 there is minus 250 multiplied by 66 multiplied by 66 multiplied by 26,000 multiplied by 26,620 So this one learners has to be equal to, this one has to be equal to 62,000, 6,372,906. Okay, let's do it again. We have negative 3 multiplied by 5 multiplied by 66 raised to the power. Then plus 3 times 25, 25 plus 5 squared minus 1850 minus minus 2 times minus 2 times 125, okay, times 66 times 26,629 plus, okay, plus 5 raised to 4 means 625 multiplied by 293,640. This one learners return is going to be equal to, okay, has to be equal to that. Mm-hmm. Then equal that to okay, 200, so just like 625, okay, multiply by 219,648. Okay, plus minus 250 multiplied by 66 multiplied by 26,620. Okay, plus plus 3 minus 3, yeah, minus 25 only, minus 66 raised to the power 2, okay, minus 1000 times 1850, then minus 3 multiplied by 5 multiplied by 66 raised to the power 4, raised to the power 4. So this one is going to be equal to, okay, you see, 6,372,960. Okay, we continue. Now we found S3 learners. I need to find S4. Then I will write my new differential equation. Okay, that will give me the x roots of that. Okay, after finding the x roots, I'll make the alpha subscript k is equal to L0 for the Q plus the x roots of my new differential equation divided by 5 because I have found this. Okay, now I'm going to put k equal 5 in the discrete formula of Mr. Ezouidi, which is equal as subscript k minus 1 over r, the sum from 0 to k, combination n minus r is k minus r, n raised to the power r, between parentheses, because 0 for the q raised to the power k minus r times n r minus 1 over q. This one learners has to be equal to, this implies that s 5 minus 1 of order r will give you s4 of order r. Okay, after making the extension of this by that, saying I will obtain the last generalized discrete formula of me, okay, for any integer formula function. So s4 of order r equals 4 times choose 1 combination n choose 5 and 0 for 2 raised to the power 5 minus combination n minus 2 choose 3 and squared times a0 for 2 raised to the power 5 times n1 for 2 plus combination n minus 3 choose 2 and 3 n cubed, okay, times a0 for the 2 squared, okay, times n2 for the 2 minus combination n minus 4 choose 1 n raised to the power 4 times 0 for the 2, okay, times n3 for the 2 plus n raised to the power 5 times 4 of the 2. You see this as 4 So this one will give you for any n degree polynomial equation the coefficient, okay? And the second coefficient, because the first coefficient is s minus 1, the second is s0, the third is 1, the fourth is 2, the fifth is s3, and the sixth is s4. Now we dive into this one. So I will apply this one in learning, and then I'm going to find the value of the s4. Then I'll make my own conclusion how it goes, how can I solve in solve this equation to the power 5. Of course, I am still in level. Okay, now I will just write s4 equal combination 4 to 1. 5 plus 5 is 1 times 66 is equal to 5 minus 3 to 3 is 1 times 5 squared, 66 squared times 1850 plus combination 2 to 2 is 1 level below this step. Okay, times 5 cubed times 66 squared times 26,621 minus 5 raised to the power 4 times 66 raised to the power 1 times 219, 648 plus 5 raised to the power 5 times 966,616. Okay, let's calculate this one and we'll talk the value of this. So I will start. I will start from the left hand side. We have 4 times 66. I will write 4 minus 66 raised to the power 5. Okay. Then minus 25 times 66 raised to the power 3. 66 raised to the power 3 times 18 means 1815. Okay, plus 125. Okay, times 66 squared. Okay, times what level? Times my cubes 26 times 620. Then minus 5 raised to the power 4 is 655. Minus 655 times 66 raised to the power times 219, 219, 649, 649, okay, plus 5 raised to the power 5, raised to the power 5, minus 966,669. So this one learners has to be equal in fact to we have 419 million, 419 million, 694, 694, then 429, 429. Okay, now I will make my own conclusion. I will proceed by learners. I will write my equation. Okay, okay. This is now my equation that I obtained. So this is that I started with. This is my original fifth degree equation. X5 minus 66 x4 plus 1815 x cubed minus 26,621 x squared plus 219,658 times x minus 966,627. Now I will this one, after finding now the s subscript n minus 1 over the r, I will write my Newton equation as the other x equal x raised to the power 5 minus s0 for the q raised for the r x raised to the power 4 plus s1 for the q x cubed minus s2 for the q x squared plus s3 for the q x raised to the power 1 minus s4 for the q has to be equal to 0. Then after calculating the coefficient, you see that all the coefficients are different, 0 except S0 for the R or the Q is going to be is equal to 0 because this one is the sum of extremes. This one learners is in fact okay is equal equal to what? Equation x equal um, substitute this one learner is going to be equal to x substitute 1k okay usually plus 2k plus 5 1 2 3 4 okay this is x1 upon the 2 plus x2 upon the 2 plus x3 upon the 2 plus x4 upon the 2 plus x5. These are the exits of this going to the power 5 that I'm going to find. Okay. Now learners, we can say that uh, S1 for the Q is 1,850. S2 we calculated or the R for the Q is 93,225. And S3 for the Q is 6,372,960. And S4 for the Q is 419,694,450. Therefore, I will write my equation. So this is the polynomial that had been derived from the original one. Okay, so here x equal x is 3.5 plus 1,850 x cubed minus 93,295 x squared plus 6,372,960 x power 1 minus 419 419 uh, 19,694,429 equal. Therefore, learning the roots of this polynomial to the power 5 are like that. There is a relationship between a fifth degree polynomial equation, fifth degree, fifth degree polynomial equation, and sixth degree polynomial equation, and their x roots has to be written as equality, as equation. Sorry. So therefore, beta subscript k from 0 to 1, 3, 2, 3, 4, because it has 5 roots for fifth degree polynomial equation, has to be in fact equal 042 plus yk, k belongs to 0, 1, 2, 3, 4, okay, divided by 5, which is equal also to 042 plus xk from 0 to 5, because I'm working with unlimited power 6 now. If you see this one, meaning that the quotient or this method you extend the power. Okay, so let's focus first on the x roots of my fifth degree from the equation, then we are going to prove uh, the x roots. So you can see that the x roots of this from the equation learners are the following. So I'll just come here. Sorry, go back. Just like that, step by step, if possible. So these are the first three roots and the first three x roots of my new fifth degree from the equation I obtained. So the roots are in fact negative 11 plus 5 cube root of 1,332 times exponential 2k pi pi over 2. So this one has only one root, okay, which is in fact the real two real roots, okay, from 0 to 2, isn't it? Or real, okay, two real roots. The other are complex, okay, meaning the first x root is negative 11 plus 5 times the cube root of 1,330, because k is going to be equal to that. Okay, this is the first one. The second root, when k equals 1, k it will be complex. When okay, so we have only one root here, and the two other are complex. Now we move to the next part. Also, this is the exits are like that. This is we call the root exits of my degree from the equation that I obtained. Okay, and what else? And what else? Let's see what's done. Okay, this is of course will be 5. Okay, 5 minus. Okay, I will just write here. Okay, it will be 6 multiplied minus. I calculate 6 cubed. 6 cubed. 6. This one is 66. This one is 66. I will just write 66. 66. 66. Minus. Okay. This is 1. X equal. X equal 66. 66 outside. Just over here. So we told now I will figure for you how we solve this fifth degree function. Here, learners, we extend our limit to the power 5 to a new limit to the power 6. Therefore, here of x has to be equal to x raised to the power 6 minus 66 x raised to the power 5 plus 1815 x raised to the power 4 minus 26,621 x cubed plus 219,648 x raised to the power 2 minus 966,669 x plus mean 0. Here is the last term, which is L4 and 5 and 4. Now learn as we used before. So it's clear this is let's focus on this only to the power 6. Extending our original fifth degree equation, we obtain a limit to the power 6. To find out the roots of this polynomial, we should determine the values of SR ODQ relative respectively to the R of ODQ, where R learners belongs to the set of numbers from -1, 0, 1, 2, 3, and 4, and 5. Now we will repeat the procedure that we did for the previous, let's say, fifth degree for the equation, but now n as going to be equal to 6. Just substitution. Now just calculation learners. So as we told that, okay, it will be, of course, I will erase this one. Okay, this is 0 equal there. Okay, if this is 0 now, 0 here. Therefore, learners, we use the notes, we use the formula of Mr. Murad Sultan Ezouidi, HSL, which has been written as S subscript k minus 1 over the r equals the sum from 0 to k, combination n minus r plus k minus r, n raised to the power r between parentheses, u raised to the power 2 raised to the power k minus r, times what learners times r minus 1. For k equals 0 learners, we should write the sum from 0 to 0, combination n minus r, choose r, n raised to the power r between parentheses to the power negative r times n r minus 1 equal to equal then the factor to 1, which is s minus 1 of n r. Okay, so this one has to be fact in terms of combination. It will be combination and choose minus 1%. Has to be equal to combination and choose 0, which is going to be equal to 1. So by convention, this one is going to be equal to 3k. For k equal 1, we write 0 for the r equal the sum from 0 to 1, combination n minus r choose 1 minus r, n raised to the power r. Between parentheses, you get a 0 for the q raised to the power 1 minus r times the r minus 1. Now, learners, you make expansion, you make expansion, okay, and you will note that a 0 for the r is equal to 0, simply because the sum of the sixth axes of these sixth degree from the equation are 0, because a 0 for the r in fact equal x1 plus x2 plus x3 plus x4 plus x5 plus x6 equals 0. Okay, and we note that the sixth axis is equal to negative 66 because the first factor is x, x minus 0. For x, x equals 0 will be a wow, where, let's say, x roots of my sixth degree from the equation is going to be equal to negative 66. Okay, because alpha subscript k equals 0 is going to be 66 minus 66 divided by 6 will give you 11 minus 11 divided by 6 will give you 0 divided by 6, which is possible, which is equal to 0. Okay, now we'll calculate. I'll calculate now known as the coefficient of 0 become negative 6 multiplied by 66 plus 6 times 66. So this one learned plus 6 times 66 times 6. So this one learned is going to be equal to. Now I will proceed. I should find now the value of S1. To find S1 learned you should, okay, as you are trying to solve the formula to the power n, you should use the same formula of me. According to me, according to my formula, you can find s minus 1, s0, s1, s2, s3, s4, and s5. And these coefficients of any n degree polynomial equation are summarized, okay, in the discrete formula of Mr. Murad. And for any coefficient of the new and the different equation that we will try to find has its own discrete formula that had been derived from my discrete formula, from my general discrete formula. Okay, so this is the value of S1. I will focus on the S1 learners, this one mean. It will be S1 equal negative combination 1 plus 1 times combination 1 plus 2 times a 0 point plus n squared x. I will calculate this. It's possible, of course. So I will immediately focus on this one. I can see that negative 6 choose 2 means what? Okay, 6 choose 2 is negative 15. Why negative 15? Because this is negative times 66 times 66 plus 66 plus 66 squared times, sorry, plus 6 on the squared plus 66 plus 6 squared plus 6 raised to the power 2 times, because this is 6 squared, okay, times what? Times 1850. This one learners in fact has to be equal to a noun. Therefore, we wrote S1 is equal to 0. Now, of course, one thing. S minus 1 is equal to 0. S0 is equal to 0. S1 is equal to 0. Means that the product of the x loops, the first two product of the x loops, the first, the sum of the first two product, okay, of the x loops will be equal to 0. Okay, so now I will continue, I will proceed. I want to find learning S2 of to find S2, my kids, you should take like 3 in the discrete formula of Ezouidi, which has been derived or written as that. S2 for the R equal combination 2 choose 1, combination n choose 3, and 0 for the curator of minus combination n x 2 choose 1, n squared is 0.2 raised to the power 1 times 1 plus n raised to the power 3 times 240. Now we'll make calculation of this. It will be in fact, and there is everything. I'll just write okay, make it clear so that you can see if possible. Okay. I will go down. I will go down to appear this down. I will calculate this one. See this one? I will do this in the we have 2 times 6 to 3 means 20 times because 6 to 3 is 40. So it will be 4. 4 is sorry. Not this. Now it's 4. So 4 times 66 times 66 raised to the power what then? 66, 66. Okay. This is 1 is 6. 2 is 50. 3 is 20. Means 2 multiplied by 10 is 40. Okay, 66 to the power 2 minus what? Minus 4 multiplied by 36 multiplied by 66 multiplied by 1850 plus 6 raised to the power 3 is 260 multiply we are here 6 raised to the power 3 is 260 multiply by 26,620. So this one matrix has to be equal to 260. Now I need to find S2, S3 one. To find S3 learners, you should do as before. Minus what we need to put K equal 4 and this formula of me. Okay, and according to me, S3 of all the R is equal to minus combination feature 1 times combination interest 2 times a 0.2 upon 4 plus combination n minus feature 3 times n squared times a 0.2 squared times a 1.2 minus combination n minus feature 4 times n cubed times a 0.2 raised to the power 1 times a 0.3 plus n raised to the power 4 times 3. This formula that I already said now, okay, is called the will help you to give you the value of the fifth official of your new FPD from the project. And this formula has been generalized in nature. Okay, so I will now make substitution by this 2 comes here. This is a S3 values just right from the beginning. Negative 3 choose 6 choose 4. This is 6 choose 1. 6 choose 2. 6 choose 3. This is 6 choose 4. When the learners, I just write negative 3 multiplied by 15. Negative 3 multiplied by 15 means negative 40. Times what? Times 66 raised to the power plus 4 choose 2 learners is 6 plus 6 times 60 times 36 first plus 6 squared times 66 squared okay, times 1850 minus 3 times 260 minus 3 multiplied by 216 because 6 is important times 66 times 66 is to the power times 26,000 times 26 times 621 plus the last term is 6 raised to the power 4 means 1000 means 1496. Okay, I will write plus 6 raised to the power 4 as it is. Okay, multiplied by what? By 219. That's 1000 219 614 This one, my kids, has to be equal to this one. Equal what? Equal to 1. And this one is going to be equal. Okay, now we calculate S3. We need to find S4 for this sixth degree equation because we need extension. Okay, so learners, our term, or according to me, S4 of order R when substituting or when setting k equal 5 has to be equal to the sum from 0 to k 5 combination n minus 5 choose 5 minus 5 n raised to the power r 2 parentheses negative and 0.3 raised to the power 5 minus 5 times and r minus 1 of 5. This one learns after developing this formula, okay, I will focus on the last one. Okay, so I will just write this implies that S4 of order R equal learning what equal in fact to combination 4 choose 1 times combination n choose at 0.2 is equal to 5 minus combination n minus 2 choose n raised to the power 2 times n 0.2 raised to the power 2 times n 1.2 plus combination n minus r n minus r okay choose 2 times n raised to the power 3 times n sorry, times n, as a root, okay, times what learners, okay, times, okay. So, we told that times what for my kids, we told times, okay, times, in fact, two, we told that this one, this is S4. S4 is a general, let's say, discrete formula of me that had been generalized, okay, from the previous field. Okay, of Mr. Murphy comes with the course. So this one I'm going to calculate the learners and I should find the value of n. Look here, means that the S4 has to be equal to 0. You see this one? 4 choose 1 means 4. 6 choose 5 is 6. So it will be 20. I will write it. Multiply by 66 raised to the power multiply by 66 raised to the power 5. Okay. Then minus 4 multiplied by 36 minus 4 multiplied by 36 because 6 is 4. Multiply by 66 4. Multiply by 66 raised to the power 3. Okay. Multiply what? Multiply what by 1850. Then plus 3 times 260 plus we multiply by 260. Okay, 260. Okay, multiply by 66 squared. Multiply by 66 raised to the power 2. Okay, multiply by 26,620. Multiply by 26,620. Then minus 2 multiplied by 1,296. So minus 2 multiplied by 6 raised to the power 10, 6 raised to the power 4. Okay, multiply learners, multiply by 66 only. So this is 66 raised to the power. Multiply by 219, multiply by 219, 640. 640 plus what? Plus 10 plus 6 raised to the power 5 multiply by 6 raised to the power 5 multiplied by 996 multiplied by 966,669. So this one moment in fact has to be equal to 0. You see, S4 is equal to 0. We use calculator, we found that it's going to be in fact equal to 0. Now I need learners to continue. I should find S5. Okay. S5 means S subscript n minus 1 or k minus 1. K denotes Okay, it has to be equal to 6, and 6 minus 1 is going to be 5. Therefore, I need a spot of order R. So, putting k equals 6 in the discrete formula of Mr. Murad Sultan Ezouidi, this is the discrete formula, the general discrete formula. Okay, and after simplifying it, we will obtain uh, the seventh, the seventh, uh, let's say, okay, we will obtain as 5 over R equal minus combination 5 choose 1 and 0 for 2 raised to the power 6 because the highest power is 6 plus L squared times 0 for 2 raised to the power 4 times 1 minus included times 0 for 2 raised to the power times 0 for 2 plus n raised to the power 4 times 0 for 2 squared times included minus in fact n raised to the power 5 times 0 for 2 times L4 plus n raised to the power 6 times L5. Now we substitute, okay, and then we find that the value of S5 is fact is equal to negative, okay, 3 equal negative 82,716 million and 49,156. So let's calculate this. After you can do this by yourself and then the kids, no problem, I'll do this for you. Okay, this is the last step to rewrite your sixth degree from equation. Okay, so I will write negative 5 multiplied by 66 raised to the power 6 given plus 36 plus 36 times 66, sorry, times, times 66 raised to the power given multiply by 1,850. I'm here now. Okay, finish this. Now I'm here. Now it's continue. Minus what? Minus 216 multiply by 26,620 plus 6 raised to the power 4 plus 6 raised to the power 4. Okay. Times 66 times 66 squared times what? Times this 290,640 times 290,648. Then minus 6 raised to the power 5 minus 6 raised to the power 5. Okay. Times 66 times 66 times what makes this times 66 times 966,669. So plus 6 raised to the power 6 multiplied by 0 and multiplied. Okay. So this one is going to be equal to, okay, I will repeat again. We call that, I will start now from this one. We call all the first, the beginning, okay? So we call minus 5 multiply by 66 raised to the power 6. Okay. Okay. Then plus 66 is plus 66 is minus 66 plus 36. Okay, plus we call plus 36 right? Plus 36. Okay, multiply by plus and minus yes, multiply by 66 raised to the power 4. Okay, minus 1,850. I will go step by step. Okay. Then minus, I'm here now, minus 260 minus 260 multiplied by 66 raised to the power 3 multiplied by 26,621. Now I'm here. I will have equal sign. Calculate it. Plus now 6 raised to the plus 6 raised to the power 4. Okay. Multiply my kids by 66 squared. Okay. Multiply by 219. Okay, then 219. 640. Okay. Then I can remain only left equal minus 15 minus what? Minus this. Minus 6 raised to the power 5 times 66 times 66 times times forget minus 966 690 and 69. So this one in fact equal to what? You see negative 82,760 negative 82,760 million and 49,000 and 49,000 and 152. 150. Therefore, now we calculate the seventh option of my second degree equation. Okay, after extending the power. I will proceed now, learners. I'm going to make summarize. Now, I will write my new second degree equation as the following. You can note S0 equal S1 equal S2 equal S4 equal 0. But S2 for the R equal to 160. S5 equal to negative 82,071 million and sorry, okay, uh, we called 82,760 million and 49,150. I will write first my polynomial to the power 6. Okay, that is relative to the S that came in from R I already calculated. So P of x has to be equal to x raised to the power 6 minus S0 for the R x raised to the power 5 plus S1 for the R x raised to the power 4 minus S2 for the R x raised to the power 3 plus S3 for the R x squared minus S4 for the R x plus S5 for the R equal to 0. I will make substitution, then I'm going to solve this. Therefore, P of x are in fact equal. Okay. This is P of x. Therefore, P of x equal x raised to the power 6 minus S2 for the R x cubed plus S5 for S5 for the R equal 0. I will write this as x raised to the power 6 minus 160 x cubed minus 82,760 million 49,150. I will use this formula again. I will write S1 for the R dash equal negative S2 S squared plus 4 times S5 for the R. So I will calculate this one. S1 for the R equal negative 216 squared plus 4 times negative 82,716 49,150. I'll calculate use my calculator. So this one I will multiply by 4. This one by 4. Multiply by 4. Then minus 216 minus 216 squared. This one is equal to what value? Equal back to equal yes. You see equal to what? Equal learners to negative. Okay. I read from here one. Okay. Okay. Will be equal to 330,864 million 243,260. Okay, so this one, in fact, if you are going to, you see this is negative, I will put now negative, this is implied that negative S1 for the R dash equal positive number. Means you will get 3 points. Okay, I will now divide this by minus 1 if it's possible, then and try to find the root. Divide, divide by between parentheses minus 1. I will explain it later. So this one is equal to, okay, 32,664,242,260. Okay. I will put this is to the power 0.5. Raised to the power 0.5. Okay. I will immediately see that this one is going to be equal to the square of 575,250. Okay. Now I will move. I will make modulus. So x3 equals in fact to s2 for the r plus root of negative s1 for the r, which is 575,201. Therefore, I will write it as 260 plus 575,208 divided by 2. Okay, so it will be in fact 287,704 times exponential 2k. Okay, for this equal. Therefore, x of 0 to 2, of course 1 is included, is the cube root of, okay, let's see. Okay, so we continue. Okay, so we continue with that. Now I will proceed. So therefore x of 2k from 0 to 1 to 3 equal to 287,712 explanation 2k I pi. I should now, let's say, write this as that, but exponential 2k I pi divided by 3 because the root has to be equal to exponential 2k I pi. Okay, here we obtain 1x reduced, which is root, real, sorry. Therefore, alpha subscript k from 0 to 1 is a 0 plus xk. This one. Okay, 7066 plus uh, 287,712 exponential to k I pi over 3 divided by 6. Let's focus on this one, and we should appear that it will be 216. I will divide this by learners, or this one we need 278, 278, 278, 712, 712. I will divide this by 216, so it will give me exactly 1334. 2, okay, 777. So it will be 287, 287, okay, 287, 287, 712 divided by 216. So it will be 1332. That's why here we put 6 out and we make inside 150. Now, these are the roots of these are the first three roots of my sixth degree polynomial equation, and at the same time my fifth degree that I start from the beginning. Okay, now I should continue. X is to the power 3 is equal to S2 for the R minus root of negative S1 for the R, that's divided by will be 216 minus this. After making calculation, it will be negative 287,496. This one has to be equal to 66 raised to the power. Let's calculate together. We have what? 216 minus 575,201. This one equal divided by 2. I will divide this by 2. So this one is equal to what? Equal to negative 287 486. I will divide this by 66 raised to the power 2 divided by 66 raised to the power 2. It has to be equal ratio of minus 1. Wait, sorry, 3. Okay. So this one is equal to minus 1. Minus, I write it as 66 raised to the power 3. And minus, you see minus? Minus, I wrote it as exponential I5 times exponential 2k I5. So this one is going to be equal to 66 cubed, okay, times exponential 2k, 2k plus 1 pi over. Therefore, x and xk from 0 to 1, 2 is 66 because the cube root, this is x cubed, equals 66 cubed times something. Therefore, x subscript k from 0 to 1, 2 is 66 times this one. Now the roots are L0 plus xk divided by 6. L0 is 66 plus 66 exponential 2k plus 1 pi over 3, which is equal to 11 plus x times 11 exponential 2k plus 1 pi over 3. This is for the sixth root, or the sixth degree polynomial. For the fifth, you should ignore 1k equal 1 because it will be 11 minus 11 is 0, and 0 is a root of the sixth degree polynomial equation. But it's not a root for the fifth degree polynomial equation. Means the only roots here, just ignore the 1. Suppose that the 1 is not written. So the first, it will be 2 times 0, it will be a complex number. The second, okay, when k equal to, it will be also a two complex number. These two roots has two complex number. And this one, okay, you have 1, okay, 0, 0, okay, 1, no, 2, no. So we have, I have two real roots and two real roots and three complex number for the fifth degree polynomial equation. Now, I comes here, I come back now, look here, I will go to calculate the back. Now I'll go back to the fifth degree polynomial equation that I started with. Okay. Yeah, okay. This one. We call that alpha subscript from 0 to 1, 2 is, I will take this one. Me, I will make notation from this. I will use my calculator. Then I will come here. Yes, this is the roots we found. So the roots are 11 plus, of course, here we should ignore the 1. Okay. And xk is okay, 66. Okay. And here we put that. And come here. So, so wait, okay, we thought this is the first y1. Okay. And okay, 5x is 66. Yes, 66. Yes, 66 multiplied by 5, we did it here. So this is already as okay. 6 multiply, or I would like to, it is 200. Yes, write it to. I will write this as that. This one. 28771. 287 Okay. Now, my kids, I will approve. Show you the example. Okay, this one, you see this one? I'll put here. I'll put after. Okay, okay. Now we calculate this. We told the roots are 11 plus real root and 1. minus 11. This one will use. I'll come here. This one, I will use this. 1k equals 0, it will be 1 plus cube root of 1 Okay, go back. Okay, yes, I will use calculator now. So I'll just write 1332 cube root raised to the power 10 third. 1 divided by okay, 8. I'll make plus what? Plus 11 because exactly plus 11. So I'll make copy for this, then I will use filters to see the first one. Okay, okay, equal plus, let's copy, paste now, raise to the power to the power 5, minus 66, minus 66, multiplied by my real root, raised to the power 4, okay, plus 1850 multiplied by, okay, raised to the power 3, raised to the power 3, then minus 26,621 multiplied by 20 plus 290,648 multiplied by what? By multiplied by 11 plus root of the root of 1,350. Then minus what? Okay. Record. Okay. Okay. Let's do it again. Control. Let's come it down first. Mm-hmm. Mm-hmm. Open that. Okay. And do it again. 1, 3, 3, 4. Raise it to the power. Here, top will be here raised to the power 2 plus. Mhm. Okay, raised to the power 1 divided by 2. 1 divided by 2. Raise it by 6. Now, we come. Okay. 1, 3, 3, 2. Raised to the power. Open parentheses. 1 divided and divided. 1 divided. Right. So this one is okay. Plus 11. Okay. Yeah. And then we need to do stuff. Let's look at this one. Okay, now I will use this one. Okay, okay. I will raise this to the power 5. Okay. Minus 66. Minus 66. Multiply by. Shit, shit. Yes, yes. Minus 66. Multiply. Multiply by. Multiply. And finally the calculator is what will be multiplied by control. Of course, raised to the power 5 to the power 4 plus 1 8.5 times control G raised to the power 3 multiply okay minus minus 26,300 times control V square. Okay, plus, okay, 219, 600. Sometimes I put calculator will start, okay? Times what matrix minus control V. Okay, so this one is a fact equal to what? You see, 966,668.99999, which is in fact equal to this. And we can do one minus and 966,669. So this one is equal to negative 1.10 raised to the power negative 26. يعني approximately 0. Okay? But here this calculator makes like that, but here it's gonna be 0. Okay? Now our come is here to make, I will ask a question. I will tell him solve this question. Okay? Look now what to do. This is Murad Sultan Ezouidi, pioneers in methods. Okay? Pioneers in methods. Now we just come here. I will make mm, GeoGebra. I can do it. Okay, I will make mathways. Mathways. Okay. Solve. Look, solve. I can solve for this. Okay. Here I can. Now I will go to another mathways. Solve. Solve. Mathways. Mm-hmm. Algebra for the solving. This one now. He will use graphs and he will give one of them. No, I think this one or something like that. No, I think this one. Fancy. No, not this. Okay. So much ways you can do. Chat GPT, yeah. Chat GPT. Chat GPT. Another chat, right? Promise. No, now. Solve. Okay. Exactly. This polynomial equation of degree 5. To find the roots, this equation we can use numerical method or sample techniques such as factorizing, making factoring, or tools like rational root theory to test possible rational roots. So it seems like I can do more. Okay, he can do it. It's good. Okay. Allah. Okay. Now we'll thank you for listening. Well, just I will show you something. Graphic. Let's say that. Let's say that. So, this one. This one. This one will give you only one way. He can solve the others. Oh, not this one. Not this one. Yes. Okay. Look at what to give him. He will solve by root of x using graphs, of course. Okay. Look, the only one solution. He wrote x equal cube root of 1, 3, 3, 2 plus approximately. Why? Because he used only graphics and he stopped. He doesn't has a method like me, okay? But he gave this. This is correct because he used graphics, okay? He used what? He uses graphics. Okay. Look what we told نحن before. You see 11 plus this one. Okay. What is it? Comes here. You see 11 plus cube root of 1332 exponential 2k at power. This is of course according to Mr. Murad Sultan is really and according to his method. But problem math solver here he uses graphics. he just uh, he just used the approximation method to give an approximation answer when the curve cuts the x-axis. Okay, cuts the x-axis here in this point. Okay, we just found one. But there is another also real number. Okay, because we told we got three complex numbers or uh, two real numbers. I will go back to here. So this is okay. Yeah. Here we have only this is total six digits only code. Therefore, now look here. Look what to give him now. This one, he got an answer. Okay, look what to do exactly and see the intelligence of Mr. Sultan is really wow, something really incredible. Okay, okay, six, okay, 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 okay. Mhm. Give me time, please. This one is it. 16. Now this one. Okay, please just one tell you the kids. I'll give him this one. Because we get only wait allow you fail after making the extension. Okay, thank you. Yes, this one. I'll give him this. I obtain it from the previous one. Okay, خلاص. This is no need. There is all of them. So, okay. Here out. You see, 5 cube root of 132 minus 8. He used the method of graph. I graph. Okay? Look here what we told what is it? We told that, you see this one? Minus 11, sorry, minus 11 plus, this is of course, 60 to divide, 3 divide, 63, 63. So we told that, I will use calculator, calculator. We have 330, 330, 330 divided by 6, divided by 6. The answer is 55. Yes, 55. So this one, you see, the x roots of the fifth degree that I gave now, in fact, are like that. Negative 11 plus 5 cube root of 1332. Of course, exponential something. I will just take the real numbers. Okay, how it comes here. What is this one? I will try to reduce this if possible. Okay, you see? You see this one? This is the method of Mr. Marshall probability. That will give you for any integer probability equation. This is the graph. 5 cube 1332. 5 cube minus 1. Okay? But he gave only one. But there is another solution. Okay? He can find it, which is negative 11 plus 55. Okay? Because this is, of course, it's complex number. Okay? Now look what to do here. Learn, I want to show you something that now plus even the graphers can do for solving. Just one moment. Okay, okay. Now, Sorry. Sorry, not here. Okay, this is say yes. Here learns. Okay. Contains Murad. Ooh. Oh, no, I will class. I will calculate. I will this one. Now I give him this. Look what to do exactly. This is polynomial to the power 7. I will ask him the same question. And he will be stuck. Can you? Sorry, I can't do it. Okay. Look, enter. He is stuck. You see? Detect this equation. We cannot solve last time. Okay, I will also annotate where is this. I will give him. Okay. Of course, x is to the power 5. X 5. Okay, مش مشكلة. I will do it. خلاص. Okay. So this one, he told you graph. He can solve. He can give also the correct answer. You see, let's see Mr. Martin can give always. What he told polynomial x كذا كذا. Okay. يلا السلام عليكم. I'm going to prepare myself to go